I haven't taken time in the last video to actually explain what linked lists really are. So just imagine three people holding hands, Mario, Luigi, and Bowser, for example. If we ask Mario here, who's the next to you, he's gonna say Luigi. And if we ask Luigi, he's gonna say Bowser. So how linked lists work is we are continuously asking for the current node, who is the next to him. And yeah, that's the basic understanding of linked lists. So now let's get back to our code last time. Last time we were here. And we had a problem. Which is that the first value is initialized to 0, but we don't have any 0 here. I've actually did my researches, and if you look at the list create method here, you can notice that we have a malloc size of node. What this actually does is that the value here in C is initialized to 0. So the value here of the node is actually 0 and not null. So that's why we get the 0 at the beginning here. But since we already started, we're going to continue with this implementation and continue with the rest of the method we have to implement. So we implemented list create, list push front, and as you can notice here, we did list push front as adding an element to the end of the list, but this is not correct. It's actually add element to the beginning of the list. But we're just gonna rename this method to list push back. So push back here, and continue with this implementation. Push back. Yeah. And now we can do the push front. So how the push front works, it simply adds an element to the beginning of the list. So which means that the first element is going to be the value that we're going to insert, and the rest of the elements are going to point to the next one. I think that doesn't make sense right now, but let's just do it. List push front, so node push front in value so we're gonna do our usual null here. If it's null, if the first node is null, it means that we can just say node dot value is equal to value, and node dot next is null. Right, and then we can just return the node. So why is that? Is because the first node, we don't have anything in this example. So the first node is going to be the node that you're going to insert. Hope that makes sense. Also, if the first element is not null, it means that we are now on the first element, and it's the first element we have to move, right? So let's create the head of the node. Head is going to be equal to list create and then head dot value is the value, and head dot next is gonna be equal to the node actually. So how that works, let's say we have 1, 2, and 3, and we want to insert we want to insert let's say 7 at the beginning. If you want to insert 7, it means that the point we're gonna create a node 7, right? And the node 7 is gonna point to the head. And in our example here, the head is 1. So, knowing that the head is 1 here, and we are actually saying that the node 7 is becoming the head, it's simple. So to actually show you how that works, here I created the first node, the head that we're going to insert at the beginning of the linked lists, right? So after that, we're going to say that, yeah, this is it. The next is equal to the node, and we just have to return the head. How that works, because the head points to the next, points to the node here, the initial node. And knowing that it points to the initial node already points to the rest of the list. So we don't have to do anything, and we just return the head. That's really easy. So let's try to see if it works. Node push back, push front, say 19 node, and try to push to print the list here and there. Actually, let's add a print ll. Let's add a printf here. That's for formatting. Okay, and as you can see, it works. We have 19, 0, 20, 20, 20. That works perfectly. I don't want the video to be too long. I think we're gonna continue in the next video with pop front, delete, and size.